Ansible is a powerful IT automation and orchestration engine that is simple enough for everyone in your IT team to use, yet powerful enough to automate even the most complex multi-tier IT application environments. In this video tutorial, you'll learn just what Ansible is and what you can do with it. We'll review some Ansible language basics, install Ansible, and then show you some basic Ansible commands and playbook runs. We'll also review Ansible Tower and Galaxy, and finally, how you can get started with Ansible. Let's talk about the three things Ansible is. First, it's the automation language that enables you to describe an end-to-end IT application environment with a playbook. It's also the underlying automation engine that runs the playbooks. Finally, we have Ansible Tower, which is the enterprise framework that helps organizations more effectively control and manage their Ansible automation. Ansible has a number of qualities that make it the most rapidly growing automation platform in the world. First, it's extraordinarily simple. Playbooks are human and machine readable, so no special coding skills are required. And even people in your IT organization that don't know what Ansible is can likely read a playbook and understand what's happening. This simplicity means that you can start to use Ansible to do real work with it in just minutes. Ansible also works like you think. Tasks are always executed in order. Altogether, the simplicity ensures that you can get started quickly. Now, simplicity is great, but to be really useful, you also need powerful features that ensure you can model even the most complex of IT workflows. In this aspect, Ansible is batteries included, right out of the box. It can manage the infrastructure, networks, operating systems, and services that you're already using today. Together, Ansible's capabilities allow you to orchestrate the entire application and environment lifecycle regardless of where it's deployed. Finally, Ansible is completely agentless. We rely on industry standard and trusted SSH and WinRM protocols to automate. There are no agents or other software to install on the systems you're automating on, and no additional firewall ports to open. With no need to separately stand up a management infrastructure, Ansible further reduces the activation energy required from your team to start automating today. In a world where IT complexity stymies even the most basic of IT tasks, Ansible provides a much-needed respite and path forward, enabling teams to crush productivity-stealing complexity. What can you do with Ansible? Nearly anything. Many folks like to categorize Ansible as purely a configuration manager, and although yes, we can do that, it's just the tip of the iceberg. When you couple configuration management with orchestration, you can start to model complex multi-tier deployments with ease. With Ansible, once one person on your team automates something, everyone on the team now knows how to do it. Ansible architecture is fairly straightforward. To execute actions on a remote system, we need a few things. Inventories, which are essentially just lists of hosts, and playbooks or commands which describe the desired action. Ansible then takes action via a transport. SSH for Unix, Linux, or networking devices, and WinRM for Windows systems, or even APIs for cloud and other services. Ansible modules control the things that you're automating. They can do everything from acting on system files, installing packages, or making API calls to a service framework. Ansible is available from several places. While we recommend getting started with the OS-specific packages we provide via EPEL and app, you can also grab Ansible and its requirements from PyPy, or direct GitHub source clone. Installing Ansible is pretty straightforward too. Note that if you're on a RHEL or equivalent system, you'll need to enable your extras and optional yum repos before attempting to install Ansible from EPEL. The docs do a great job of detailing all the steps for you, but let's go ahead and show you what it looks like. This is our control node. It's where Ansible is installed for our demo. For this step, I'll SSH into a system that does not yet have Ansible installed. Remember that only your control node needs to have Ansible installed on it. Next, we'll switch to root and install Ansible. And just to validate that we're all up and running, check to see that Ansible installed properly. Okay, now that we've got Ansible installed, let's look at how to start automating. First, we'll start with playbooks. Playbooks are written in the Ansible automation language, which is YAML-based. These files describe the desired end state of something. As I said before, they're human and machine readable, and as you'll see in a second, don't require any special coding skills to use. Playbooks can be really simple, just a few lines, or built up to describe entire applications as well as the environments they run in. Variables enable you to alter how playbooks run. Variables can be used nearly everywhere in playbooks and can be inherited from an inventory, explicitly set at runtime, discovered at the start of a playbook run, read from files, or even set via Ansible Tower, or also set as the result of a task. We'll talk more about tasks and how they relate to playbooks in a minute. Next, we have inventories. As I said earlier, in order to run a playbook or an Ansible command, you need a list of targets on which to automate. This is what an inventory does. Inventory lists can be built and stored in several different ways, including static files, i.e. etc Ansible hosts, or it can be dynamically generated via an inventory script that will pull a list of hosts from an external source. You can also specify variables as part of an inventory list. For example, set a particular host key that's needed to log into that system remotely. Inventories are ultimately lists of things you want to automate across. Here's an example of a static inventory list similar to the one that we'll be using in the demo today. Now let's talk playbooks. Playbooks contain plays, which have as part of them tasks. Tasks call modules. Tasks also run sequentially, so they'll work like you'd expect them to if you were to manually step through your list of processes on the command line. Next, we'll introduce the idea of a handler, which can be triggered by a task, and are run once at the end of a play. Here's an example of a playbook which has one play, 3 tasks, and a handler. The 3 dashes at the top of the file indicate that this is a YAML file. Next, we set some directives, and then move along to the tasks themselves. The hosts keyword specifies which inventory group Ansible should apply this playbook to. With remote user, we tell Ansible which user to use for remote connections. Next, we use several more directives to tell Ansible how to escalate privileges on the target systems. In this case, we're just using sudo, but can support nearly any mechanism necessary. Also note that you can use Ansible without root access. You'll just be limited to doing only the things that you would do if logged directly into the target system as your normal non-privileged user. We also added a few variables into the playbook itself. Next, we have tasks. Playbooks are self-documenting, so the name directives you see listed here serve to classify output at runtime, but also help with the readability of the playbook as a whole. Each task is given a name, followed by a module, which is what tells Ansible how to configure the target system. We start with the package installation using yum, then we deploy a configuration file using the template module. Any variables inside that template will be replaced as appropriate with the variables that we specified at the top of the playbook. Finally, we ensure that that service is started. We also added a handler here. If the configuration file is altered as part of this playbook run, then Ansible will restart the service once all the plays have successfully completed. Let's talk a little more about modules here. Modules generally follow the same structure when you call them. In the docs, you'll find a list of what we ship, along with possible directives and values. We also provide numerous example tasks for each module, all of which help you get started even faster. The example playbook we're going to demonstrate here is really pretty simple, but there are many more complex and sophisticated things you can do with Ansible playbooks. Beyond altering playbooks with variables, there are a number of ways to change how individual tasks are executed on your target hosts. We can loop and apply conditionals to any task. Ansible also has the concept of a role, which is a special kind of playbook that is fully self-contained and portable. A role can include things like tasks, variable files, configuration templates, and other supporting files that are needed to complete a complex orchestration. The docs have more information on roles, and we created Ansible Galaxy as a repository for user-generated Ansible role content. We'll talk more about Galaxy in a few minutes. Okay, now that we've covered the basics, it's time to actually automate with Ansible. There are 3 ways to run Ansible: by directly calling a module from the command line, calling a playbook from the command line, or by using Ansible Tower. First, we'll look at how to run ad hoc commands. We can run raw commands on target systems or call modules directly, but let's see what that looks like. From our control node, we'll just execute a simple remote command. Now, let's call a module. This one is really simple. It just ensures that the system is up and Ansible can access it for further automation. Oh cool, good news. My systems are all alive and ready to be automated. You can also do more complex things, like ensure a package is updated. Running one-off tasks across a number of systems is cool and all, but in order to do more complex things, we need to use a playbook. Let's look at what it takes to run these. From our control node, we'll call our sample playbook. Let's talk about the output when we run this. We get statuses of each of the items that Ansible automated. Again, the tasks are executed in order, and the output will change depending on what actually happens. For example, if the state of the target machine has changed. Now let's see what happens if we run the same playbook again. Note that in this case, Ansible reported that everything was okay. This means that no state changes were made, and the target systems were already in the desired state. However, if we make even the slightest change to the config file and rerun the playbook, we'll see that the file is updated and Apache is restarted. Ansible also has the concept of a check mode, or dry run. It's a way of validating the existing running state of your system and systems. Not all the modules support check mode, but a good number of them do, and this is a powerful way to validate changes you want to make before you actually have to change the end state of target systems. Let's take a look at this. From our control node, we'll check to see if our web servers all have the latest kernel. We can also run playbooks in a check mode. If there's a module that doesn't support check mode, such as the command module, then that task will be skipped. Note that if we change our template file again and rerun the playbook in check mode, you'll see what Ansible would do, but the end state of the systems remain unchanged. Pretty powerful stuff. Okay, we've introduced the core concepts of Ansible. Now let's talk briefly about Ansible Tower. Tower layers in control, knowledge, and delegation on top of Ansible's simple, powerful, and agentless automation engine. Tower is a UI and API that centralizes Ansible runs, which also makes it easier to integrate Ansible into other systems or workflows required for things like CI/CD or DevOps processes. Also, all Ansible playbook run output is captured and stored inside Tower, so you can easily audit the results, including who ran what job, what systems were updated, the output of each system, and so on. It even lets you map those actions back to the LDAP or Active Directory user that initiated the event. With delegation, Tower enables you to define precise roles and responsibilities so the users can only run pre-approved automations in environments they're supposed to have access to. You can even remove their ability to alter variables, effectively offering them a push-button console from which to launch automation jobs from. No Ansible knowledge or skills are required at all. Finally, Ansible Tower can ingest and tightly control access to the credentials needed to automate various cloud APIs, or even the credentials needed to run jobs on target systems themselves, which means you can safely automate without concern that your credentials can be exposed to users who should not have them. Once you're up and running with Ansible, you should definitely take a look at Tower. We have a lot of information on our site about it, and frankly, it'll help you take your automation effort to the next level. Finally, we have Galaxy. Ansible Galaxy completes our batteries included story by giving you access to thousands upon thousands of user-contributed roles, playbooks, and modules. With the Ansible Galaxy command line, you can use roles directly from this repo, but you can also easily download and customize the roles locally before running them in your environment. The great thing about Galaxy is that no matter what you're trying to automate, there's a good chance that someone else has already done it, so why not just learn from them? It helps you do real work with Ansible that much faster. Okay. Thanks for watching our quick start video. We're really confident that as soon as you begin to use Ansible, regardless of your role in IT, you'll see why we are truly automation for everyone. Ansible's simple, powerful, and agentless automation is truly something special. And since it starts providing value almost immediately, why wait to get started? For myself and the entire Ansible team, happy automating.